Hello. Today we're going to continue our introduction to the Belgian Mathematical Olympiad OMB series. Um, Today we focus on the four problems from the MIDI level. So MIDI level is actually the intermediate level. The students from the third and the fourth year in the high school are allowed to participate in this level. Let's move on. So the first question I would say is kind of counting. So you start with a close-packed triangular arrangement of the circles, which has a radius of 1, right? And all the circles are tangent to each other, so just meaning only one contact point between each pair of the circles. It's asking if the sides length is n, meaning that only n circles on each side, and how many contact points are there. The second question is asking how many wide regions. That wide regions as actually the regions in a star shape between these circles. So the number of these wide regions. And the third question is asking the total area of these wide regions. To start with, it's kind of counting, right? It's kind of counting. The first question, how many contact points between the two disks? To answer this question, we can always start with some simple cases. Yeah. So we just probably draw a table. So n. So let's see, the Cn stands for the contact point, the number of contact points for n circles. So apparently when we have only one circle, so of course there's no contacting points, right? If we have two, instead of two circles, there's two rows. Actually, we have 1, 2, 3. So we have 3 contact points. And for 3, so we can again 1, 2, 3, 4, 5, 6. So 3 plus 6, 9. And so on. And think about the k minus 1. We don't know yet, so we just write the ck minus 1. And when we have a k levels, and then we have a ck contact point. So just think about from the k point, from the k minus 1 level, we just add a new level, append the new level to the k plus, minus 1 level. And here we have a k circles, right? Just think about the contact points. So in the last layer, or level, we have actually one contact point between each pair of the circles. Since we have k circles, so then here we have k minus 1 additional contact point. And think about this one at the last one and the first one. Last one, first one. It has only one contact point with the circles in the upper layer, right? So we can have add one and add another one. And for each circles in between, for these k minus 2 circles, each one has 2 additional contact per point, right? So that's why we have 2 for each. And how many circles there? We have k minus 2 circles in between, right? And that means the ck, minus ck minus 1. So from k minus 1 level to k level, we have additional, let's count how many additional contact points here. So it's actually 3k minus 3. So actually 3k minus 3. And we can do the same down to k is 1. The down to meaning that's the same recursive equation can have ck minus 1 minus ck minus 2, and then will be 3k minus 1 minus 3, and the dot, dot, dot. The last one will be c2 minus c1 is 3, of course, it's 3 here, yeah. So we add them up, add all the equations up, and you see here we have a minus ck minus 1, we have positive, minus positive, and then minus c2, positive c2. So at the end we have a ck minus c1 equals to 3 plus 9 plus dot, 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 3k minus 3. So that is a arithmetic sequence, right? With a common difference of 3. So here, what we're going to do is to add them up. So just add them up, and you will find, because C1 is 0, C1 is 0, right? So then immediately you have CK equals to 3 plus 9 plus dot, 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 and 3k minus 3. And this one is not so difficult, right? So what you need to do is to add them up. Yeah, just add them up, and then you have the equation for CK. You have the equation for CK. So for the rest, I'm just skipping it because it's a simple addition. Second question: What about the number of white regions? Okay, so we just notice as Rn. Okay, you notice Rn region, the number of regions. So when we have only one layer, of course, there's no white region. We have 2 layers, and we count 1. And you have 3 layers, 1, 2, 3, 4. Yeah. And 4 layers, of course, I don't count it more. I just dots. So for k minus 1, we have r k minus 1. And for n is k, we have rk, of course. Just think about, again, if we attach a layer of k to the layer of k minus 1, how many new or white regions can be created, right? And we can see here, the layers here is just between each pair of the circles in the bottom. So here actually we have k circles at the bottom, so meaning that it's created a k minus 1 additional white regions. And besides, here we have also some new white regions created. So that is exactly 1 less comparing to these white regions. So we have 1 less, so k minus 2 instead. So by this, we know, okay, the rk, so the rk minus 1 is, here is 2k minus 3. Yeah, so actually it's 2k minus 3. So we can do the same again. We can do the same again, like rk minus 1 minus rk minus 2. That will give 2 times k minus 1 minus 3, and dot, 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 till r2 minus r1. So here is 1, because 1 minus 0 is 1. Add them up again. So you have rk, but rk minus 1 is gone. Rk minus 2 gone. R2 is gone. So rk minus r1 is 1 plus 1 plus. Then again, 2 and 3, 1 plus 3 plus dot 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 2k minus 3. So this is also an arithmetic sequence with a common difference of 2. Yeah. So the Cn is actually a arithmetic sequence with a common difference of so 6. So I mean not the Cn, but the ck minus ck minus ck minus 1, right? So here the R1 is 0. So you just need to add them up, and then you got the formula for the RK. Yeah, so we skip this step as well. The third question is actually asking what is the area of all the right regions. Since we know the number of the wide regions, the only thing we need to do is to calculate the area of each wide region. Yeah, for a small wide region, how large it is. So if we zoom in and just draw a regular triangle here, and we know the side length is 1 plus 1, so side length is 2. Yeah, and it consists of 3 sectors. 3 sectors of 60 degree because they are regular triangle. So the three sectors forms half circle, right? Half circle of radius 1. So it's pi 1 square divided by 2. So that is the region in the shade, shaded in gray. So what we need to do is to calculate the area of a triangle, regular triangle with side length of 2, and the minus half circle, and then we can get the area of each white region. And we can just multiply this area of the single white region times with the number of the white regions, and then we can get the answer for C. Okay, go ahead. Question number 2, quite similar with the question in the MIDI level, right? Quite similar, but a little bit more complicated. So we can use the same idea, and the 6th smallest number, it has a mean of 5. That means their sum, I will say S1 to 6, okay? So their sum will be 5 times 6 will be 30, right? The mean of the 6th largest number is equal to 15. So that's S5 to 10, right? In total, there are 10. So 5 to 10 will be 15 times 6. It gives you 90, okay? Can the smallest of these 10 natural number be equal to 2? Yes, because we did this yesterday. It can be 2, 3, 4, 6, 7, and 8. So the first 6 gives each pair a 10. So the average is 10, right? Average 5, sorry, average 5, sum is 30. And the last 6, it should have a sum of 90, but here we have already 15. So we have to calculate 90 minus 15 gives you 75. And of course, it's possible because we can easily fill in like 9, 10, 11. So here gives you already 30. And the last we get 45. And that's done, right? Then that's done. Okay, so that's possible for A. And we show already an example. Question number B, can the smallest of the 10 natural numbers be equal to 3? We explained also yesterday, it's not possible. Why? Because if we start with 3. The smallest is 3. So the smallest possibility is 3, 4, 5, 6, 7, and 8. So that will be the smallest combination of the 6 numbers. And you see the sum of them will be 33. It's bigger than 30, bigger than the S1 to 6. So that's a contradiction. That's contradiction. So B is not possible. Okay. C. Can the arithmetic mean of these 10 natural numbers to be equal to 11? What does it mean? So if it's 11 and we have 10 numbers, the S1 to 10, so all the numbers sum up will be 110, right? Because there'll be 10 numbers and the average 11, so 110. And if we draw a Venn diagram, more or less the Venn diagram, the first 4, last 4, and middle 2, right? So the first 4 plus the middle 2 is actually equal to 30. That's the first 6 numbers. The middle 2 numbers plus the last 4 numbers, the sum will be 90. So if we add the 30 and 90, it gives us 120, but the 2 numbers in the middle has been counted twice. So actually, we have to minus S, so 5 to 6. So 5 to 6. So these 2 numbers has been counted twice. So 5 to 6 must be 110. Yeah, must be 110. So that means S 5 to 6 will be 10. And the only possibility, or the largest, if we say the largest S5, the fifth number will be 4 plus 6, right? Because the distinct numbers, we cannot make it 5 plus 5. So it's 4 plus 6. So that means the fifth number should be 4 at the maximize, as the maximums, and that is not possible because we can start with 1, 2, 3, 4, and the fifth number at least will be 5. But here it's not possible to start with 4 already. So that is contradiction. So C is not possible. C is not possible. Okay, then D, what D stands for? So D is asking under the conditions, meaning that under 2 conditions, what is the larger the value that the mean can be take? So the larger the value of the mean, that means the larger the value of mean. So I'm going to make some room. And the 2 conditions are actually the first 6. The sum of the first 6 is 30. The sum of the last 6 numbers are 90. So if the average, I don't know, maybe I use A, stands for the average of all the 10. And then, of course, the sum 1 to 10 will be 10A, right? 10 times A. Yeah. And we know it already. That the 10A, or the sum of all the numbers, is actually the 30 plus 90 and the minus as the fifth number and the sixth number. Yeah. If we want to maximize, because the larger the value, so we want to maximize this number, that means we have to minimize the S 5 to 6, right? What is the minimum? What is the minimum of S 5 to 6? And I will say it's possible if we have something like 15, right? So say here we have the S1 to 4, and here we have 2 numbers, that is S5 to 6. And their sum must be 30, right? The first 6 numbers. The sum must be 30. And then we have to minimize. We have to minimize this part. So let's say it's possible to have a 15, 15, meaning that the S1 to 4 is 15, and S5 to 6 is 15, we can make it. Because S5 to 6 can be, for example, 6 and 9. Yeah. And for the first four numbers, it can be, for example, 1, 2. So then we still have to calculate 12. So that's 5. No, not because 7, because it's 6, 9 here. Maybe not 6, 9. We have to make life easier. Instead of 6, 9, we can use example 15, 7 and 8. 7 and 8. And the first ones will give you, start with 2 instead. So 2, 3, so it gives already 10, 4, and 6. So 2, 3, 4, 6, 7, and 8. So in this case, the sum of the first 6 numbers is still 30, and the S5 to 6 is 15. So then the 10A will be like 120 minus 15, so it's 105. So A will be, the max A will be 10.5, 10.5. But you may ask why, and I can show you why we cannot get it larger, because 10.5 is the max. And again, if we want to have the average, as large as possible, we have to make the S5, 6 as less as the max as possible. So instead of 15 plus 15, we can try, for example, 16 plus 14 instead. So meaning that the S1 to 6 is 16 and S5 to 6 is 14. So 14, the possible combination of 14 is actually not 7, 7, but 6 and 8, right? 6 and 8. So that means the largest number of the first four, or the fourth number, will be only 5. And in this case, it's not possible, because the biggest possibility is 2, 3, 4, 5, which gives you only 14. So the first four numbers cannot sum up to reach 16. So that is a contradiction as well. So meaning that the answer for the D is 10.5, 10.5. That is the largest possible average of all the 10 natural numbers. Okay, go ahead. Number 3, sorry. I used too much space. I make some space. Number 3, okay, maybe we can go directly to the French written problems. So to find the values, actually, to find the values of the two radicals, it's not so difficult. The first one, actually, if we see, is 1, 1, 1, 6 ones, right? And minus 222, which is actually, we can say 1, 1, 1, 1, 1, 1, minus 111 and 111. So that's the first 111 is down here. So actually you have 111,000 minus 111. And we can take the 111 as the common divisor. So we have again 1,000 minus 1. So it gives you 111 times 999. And that is the 111 square times 3 square. And of course, we have a square root. So actually the answer is 111 times 3 gives you 333. So that's the answer for the first question. And the second is exactly quite similar. Now, the second one is similar. So you can do the same. Actually, instead of 3 ones, here you have 4,050 ones. And you can do the same like 1, 1, 1. Here we have 2025 ones. You do the same factorization And here you have a 10 to the power of 2025 and the -1, which gives you 2022, no, 2025 nines, right? And then they can do it again. That is the 111, the 2025 one square times 9. 9 is the square of 3. So the answer will be 3, dot, 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 3. We have 2025 threes. So that is quite straightforward. Yeah, that's quite straightforward. Okay, number 4 is kind of geometry. Okay, and now you have similar triangles, have a circle. So that's a little bit more difficult than the geometry questions in the midi level. It says that A and B are 2 points on the circle, and the circle has a center at O, a radius 5. So the radius is 5. And it say AB is 6. So AB is 6. So in half, it's actually because it's symmetric, right? So we just consider half. The symmetric, so let's say and half of AB is 3. So you see 5, 3. So here immediately you have a 4 because it's right triangle here, right triangle out of the symmetry, 3, 4, 5. Okay. You said there is a square, PQRS is inscribed in the sector. So Q and R on the arc of AB, and P and S are on the radius. Yeah. So what is the area of the square PQRS? And our task is to find the side length of this square. So let's let this X, right? The PQ is X, okay? And we just extend this reflection line till here. So just make it larger. Just extend to here. So let's say, just name it PQRS. So we can call it maybe E and F, okay? E and the intersection point here is F, okay? So E and F, E and F. And now we see the PFO, this triangle, is similar to A, let's say G, okay? AGO, so PFO is similar to AGO. So that is also a right triangle like a 3/4/5, yeah? So here, because PQ is X, PQ equals X, so the PF is half X, and we know that stands for the portion of 3. So that means OF is half X times 4 divided by 3. So that is 2x/3. Yeah. So we know OF is, and OE, actually OE, we know it's OE is OF plus X. Yeah, it's side length. So we know what the OE is, and QF, of course, is half X. QF is half X. And we just connect the O and the Q. Connect the O and the Q. So we got a right triangle as well. So there we can use Pythagorean theorem because we know the OQ is the radius, which is 5. Yeah, so we got an equation, the OQ square equals QF square plus FO square. And then all the side lengths is represented with X. So we can find immediately what S is. But actually the square of X, what we are looking for is square of area of the square. So we need only to find what X squared is. So that's now very straightforward to find solution. Okay, that's the end for the midi level. And I hope you will have some time during the weekend so we can also introduce the 4 questions in the maxi level tomorrow or the day after tomorrow. See you then.